We're here to talk about confessions of a vulnerable developer. What do I actually need to know about security? This talk is pretty lighthearted. There's not going to be a lot of heavy information here, but I think it'll generate a good discussion, maybe some good questions. First of all, this is my first time in Raleigh and my first time at All Things Open. How many of you are locals? Awesome. How many of you came in from out of town? Just a few. Cool. Good deal. First time ATO? Awesome. That is really cool to see. All right, well, this track is a security track sponsored by Jfrog. I am a Jfrog person, so we are very happy to do that today. And please visit our booth when we're done here. I also have some awesome stickers you cannot leave without. I have all kinds of fan club stickers here. I have Dr. Strange stickers. I have, for any Princess Bride folks, I have Diego Montoya stickers. I've got Star Wars sticker and Super Frog stickers. So come see me after if you'd like any of those. All right, first of all, just a little bit about me. I am Melissa McKay. First and foremost, I am a developer. I have been for over 20 years. It's been a privilege to become a speaker. About 2 years ago, about when everything shut down, I decided to become a developer advocate because I was ready to travel. Obviously, that didn't happen, so I got a lot of practice on Zoom and doing video calls and video conferences, online conferences, that kind of stuff. I also am an author. I did spend some time the last couple years with some colleagues of mine. We put together a book called DevOps Tools for Java Developers. My background is primarily Java server-side. I became a Java champion and also a Docker captain, so I like to keep up with the latest and greatest coming out of the container world. I do have a talk tomorrow as well talking about container standards, giving you an introduction to that. Today, though, we are going to talk about security, and this is my book, by the way. When I started this talk, writing this, I realized that what I care about security has a lot to do with how much I care about DevOps. And as a developer, I was posed this question on a panel once. This is a little bit different. Why should a developer care about security versus why should a developer care about DevOps? Turns out there's a lot of similar reasons. But I mean, we're already being asked to do a lot. Developers seem to be taking on a lot more and more. I know that when I joined a DevOps team, I was pretty overwhelmed with all of the new tools and everything that I needed to learn. I immediately got, put on making sure that our pipelines were up and running for a brand new project, making sure that our build server was behaving the way it was. These are all skill sets that I did not have immediately as a developer. There were new ones that I had to accrue over time. So when we talk about security, it feels like just one more thing added to the pile. And the first thing, that I think of is, isn't this a security team expert? Is it their job? Is it something that ops takes care of? And as it turns out, it's something that we all need to care about, everyone on the team. And there are things that developers should be aware of and should be prepared for as they develop their code. So yeah, instead of blaming, the other guy or assigning the other guy all the work, or when things go wrong, pointing your fingers elsewhere, we do have some responsibility in this. And let's talk a little bit about what the consequences are when we don't pay attention to security. You'll probably hear a lot of these, and probably have if you've been to security talks. You hear about these over and over and over again, these attacks that have happened. This one, it was a pretty serious one, Equifax breach. It happened, it was continuous. It happened through March through July of 2017. That was quite a while ago, but they're still paying money out for this. They were fined quite a bit, lots of cleanup costs, $1.4 billion in cleanup costs, actually, $1.38 billion in consumer claims, 143 million customers. And this was just because of an Apache Struts vulnerability that existed that people knew about, but they didn't get updated in time before it got utilized by hackers. Here's another one, SolarWinds, familiar with this one. This was a supply chain attack. This happened when a product, an updated version of this software went out to a bunch of customers, and it turned out to not be a legit version of this software. And this is pretty serious. It added about 4,000 lines of malicious code to the Orion platform DLL. And this binary was switched on their CI system, so apparently there were some security issues there. 18,000 customers received this particular update that had a backdoor. Then we have Log4Shell. This is the latest and greatest. As a Java dev, I was really concerned about this one, going through all of my projects, making sure that I was not utilizing an older version of this. All of this has cost a lot of money, and a lot of the reason behind it is because our data is very, very valuable. So a lot of money is going into data breaches. Equifax had pretty severe fine for this. They started out at agreeing to pay $575 million, up to $700 million if that first amount wasn't enough to cover all of the claims. And what you might not have known is they already were fined in the UK £500,000 in addition to that. So pretty big deal. Some other big ones, there was the Home Depot had a data breach in 2014. They had to pay out at least $134.5 million to credit card companies and banks as a result of that breach. In 2016, they agreed to pay more money, $19.5 million, to customers that had been affected. So you can see this is continuously going on. As far as SolarWinds, we don't know yet if any money is going to be coming out of that. Seems to be still in the works. There could still be some money coming out from that breach. Another interesting one, December 2021, Capital One agreed to pay $190 million to settle a class action lawsuit for a data breach they had. And then in 2016, Uber had a huge data breach. This one was interesting because they didn't tell anyone about it at first. So they were fined a bunch of money for that. And then once everything came out into the open, they were fined more. So pretty serious, lots of money involved, and clearly developers have something that they can do to contribute to a solution. This is a slide, I've used before for DevOps talks in the realm of DevOps. And why should a developer care about DevOps is because of all of the processes that are involved, all of the communication that goes on with different teams. Turns out this is very similar to our security needs. Our security needs cannot just be limited to all the way at the left or all the way at the right. It can't be something that is just tacked on at the end. And I came in at the tail end of the previous talk. He was mentioning that shifting left has some costs. It absolutely does. In my opinion, it's necessary in some cases, but there are appropriate ways of making this happen for developers that doesn't have to be quite as painful. So these are the 4 things we'll be talking about a little bit. I'll start off with writing safe code, managing our dependencies, building our artifacts responsibly. That was something that I learned through trial and error. And then understanding, protecting, and maintaining the dev delivery pipelines. That was something that was new to me as a developer before I joined a DevOps team. I was often in the position of just writing my code, committing it, and that's all I saw. Went over the wall, someone else's problem after that. So because of all of these breaches and everything, companies have started to clamp down on these problems. They're trying to educate developers a little bit more. And several years ago, I got to do security training at my company. There's a lot of third-party organizations out there willing, to teach developers and give them a better handle on how to write their code better. And I remember the particular program that I was a part of, you chose the language that you usually wrote in, and you would go through all of these exercises to learn all kinds of things. I learned about cross-site scripting, I learned about SQL injection, I learned about LDAP injection, I learned about cross-site forgery, request forgery, and insecure cryptographic storage. And I felt pretty smart after that. I was pretty sure I knew what I was doing and was very happy with myself and continued on thinking I knew it all. Clearly, there is a lot more involved than just writing code that is safe. There's a lot more around it. There's a lot more resources out there now to describe the problems that exist as well. This page I found, it's a essay written by a group of folks for the OWASP organization. OWASP stands for Open Web Application Security Project. It is a nonprofit foundation that works with open source projects trying to improve security, for all of us. They try to keep themselves vendor agnostic. And this article is pretty funny. There's several things in here that made me chuckle. This essay was written in a way like how to write, code that is unsafe as opposed to all the rules for writing it safely. These are some of the funnier points. I loved the secure languages. I've heard this argument before, like, oh, I program in Java, we don't have security issues. And then, Log4Shell happened. And then, I program in Rust, or I am special somehow and don't ever write code or using a language that has any issues. Obviously, that is not true. Mixing languages, I like this one too. Let's see how many languages I can write in successfully and be able to know the security patterns well enough to be able to pass all of my security exams for every language. I had this issue when I started writing Docker files for containers. That was an interesting activity, and we'll look at a fake Docker file a little bit later and just kind of walk through some of the problems that I saw immediately. Here's some more. I love this one, relying on security checks done elsewhere. Someone's doing a security check somewhere, so I don't need to worry about it. Very nice. Trusting insiders. There's a very real example of that, malicious input coming from inside a company. It's a big problem. And code wants to be free, dropping source code into repositories that are accessible by all within the company. That one's really interesting to me because for many, many, many years, I used Artifactory. And I didn't even know that Artifactory was part of Jfrog. Here I am working for Jfrog now. And but as a developer, I didn't have the rights or permissions to really see what was going on back there in that system. And as a result, when I joined a DevOps team, all of a sudden I realized I needed a place to put stuff. And if you have one of those drawers in your kitchen that has just everything in it, it's got staples, rubber bands, glue, pair of scissors maybe, sticky notes, barrettes. That's what our repositories looked like, because I didn't understand the purpose behind it, the purpose of keeping all of that organized, the purpose of keeping one repository separate from another based on whether it's a production repository versus a QA or test repository or registry. These are all things that we need to consider when we're setting that stuff up, to keep ourselves organized and also to set permissions on these things. That's pretty important. I'll touch on that a little bit later again as well. All right, I'll let you go read the rest of that yourself if you like sarcasm. Excellent, excellent essay. First and foremost, developers need to manage their software dependencies. We don't talk enough about dependencies. In my opinion, this is pretty important for us. I know as a junior developer, it might be something you don't touch on for a while, because I remember my first job coming out of college and as an intern was I was put on a project and given a script to build and run, and that was it. And I was just so excited to jump in to start developing a feature, start fixing a bug. I didn't spend enough time understanding how that build was actually working under the covers. How many of you use Maven? Yeah, Gradle? NPM? Scary. PyPy? Okay, cool. This is, yeah, it is very scary. This particular graphic is pretty overused, but that concept that software is potentially made up of a ton of components that a developer does not have firsthand knowledge of cannot be understated. Applications and services that are built today are more complex than ever. Generally, good developers don't want to reinvent the wheel. We want to be as efficient as possible. We want to get our stuff done. I remember one of my bosses told me his purpose was to hire lazy developers because they were the most efficient. I turned out to be a pretty lazy developer, so I did well. The problem is, many package managers, like what we just discussed, make all of this so easy for us. We use them to collect everything we need behind the scenes. That includes Maven, Gradle, NPM, PyPy, etc. And sometimes we can get tripped up by transitive dependencies. And unfortunately, many pieces of software may still be suffering from the log4shell exploit, simply because the project doesn't pull in that library directly, but it may be pulling it in as a transitive dependency indirectly. There could be a level 1 dependency that is actually using that as its dependency. Also, that convenience of being able to use these package managers to just kind of handle all of that for us, they blind us to what's actually happening, how these dependencies are being pulled, and where they're being collected from. Unless you specify otherwise, these package managers are all going to be collecting from public repositories, unless you configure them otherwise. This means there's a ton of developers out there right now who are running Maven build clean on their machine, and they're hitting Maven Central directly. Same with NPM, they're building their node application, they're hitting the public NPM registry directly. It doesn't matter if their company is using Artifactory, if they're using Nexus, or any of the others out there that are available to manage these dependencies for you. If you don't configure them, it's not just going to happen by magic. So here's an example of where all of these actually pull from by default. Docker is a big one, too. Whenever you run a Docker pull, it's pulling from the Docker public registry. Just be aware that that is what is happening unless you configure something differently. Pretty easy to solve this, you think. Like I said, you can set up Artifactory, Nexus, Harbor, any of those. And you can set those up to actually only pull from these public repositories when your particular dependency or package that you're looking for isn't already available or cached internally somewhere. That sounds great, except there's a specific problem that is why I'm fearful for all of us using NPM without thinking about it. We've managed so far. This has been around a long time. This problem has existed forever. But in 2021, Alex Burson did a really good job of writing up a description of what this problem is. And it's called the dependency confusion attack. And it described how he was able to hack into Apple, Microsoft, and a dozen of other companies using a novel supply chain attack. So description of that, what that actually looks like, is here is a typical JSON file that describes the packages that a particular project needs to build, right? I've highlighted some of these. Notice that the versioning scheme for these indicates that anything greater than the version that's indicated there would be acceptable in this case. So if there's an update available, it'd be great to keep up with updates, right? We're being more secure. We want to keep up with these updates. Well, here's a problem. What if the build for this project is configured, like I described, that if a package isn't available locally, then the default behavior is to reach out to the public registry? That sounds okay, but what if these highlighted package names are actually internal package names and they shouldn't be available in a public registry? And it turns out that anyone can publish a package to the public NPM registry using any name that isn't already taken. So if you have internal package names and they are not spoken for in the public registry, there's a chance that someone can create one for you, and now you're in trouble. This is what that looks like. You have a corporate library you intend to get, someone publishes an awesome update, and you get that one instead. Not legitimate. And then you don't know what's going to happen when you pull that into your project and run it. So one way to protect against this is to make sure that you do not ever go to public registries for internal package names. Make sure that you don't forget to configure that step. By default, that's not how things work. Here's another example of just building other artifacts that can be a problem. This is a contrived Docker file. It kind of illustrates some of the problems that I've had myself with packaging applications that I've already created. So this was new to me at the time, building Docker containers using Docker files. I very much knew how to take care of my Maven project, my Java project. I made sure everything was internally sourced. I had all of that protected. But in the end, I needed this to be in the cloud. So I ended up wrapping up my application in this Docker image. And if you go online to look for Docker files, you'll see stuff that looks very similar to this. And the very first problem is that line 1. What I said about pulling from public registries, that first line is pulling from the Docker public registry. If you don't know what that parent image is, how can you ever think that it's safe? Make sure that anything you're pulling is at least spoken for or has documentation around it. Make sure you've done a dive into that image to make sure that it has in it what you expect. Make sure you're scanning that image. Also, make sure that you can source that parent image locally, internally, instead of constantly pulling it externally. I know when Docker decided to put some limits on pull requests, there were a lot of CI servers out there that were configured to just always pull from Docker Hub. And you might think, well, once the image is built, you don't have to build it again, there's caching. But think about how a CI server works. A lot of times we purposely wipe that cache because we want it to be built fresh. So every single time everyone did a commit, a new image needed to be built, it's pulling from Docker Hub. So a lot of CI servers had some troubles continuing their builds when that flow was cut. So make sure that whatever parent image you're using, pull it in, make sure that you have it. Lines 2 through 4, it looks like not only do we have a parent image we're unsure of, but it didn't have everything we needed in it, so we decided to throw some packages in there to make sure that our application that we really care about can run. Well, notice there's no versioning on this. Some of those packages may be old. This is something that can be easily missed during a review of the project, making sure that you are responding to any vulnerability notices or anything like that, making sure that you update these images. Those additional packages probably should be put into another parent image and combined, maybe maintained by a platform team, something that can be made available to all the developers. That would be one way to manage those updates and make sure that the base image is actually something that's okay to use. Line 6 is actually a really big efficiency and performance problem if you're not using a git ignore file. When I first started working with Docker files, I didn't know that a Docker ignore file, I didn't know that existed. And it is very similar to a git ignore file in that when you have a copy statement like this and you're copying a bunch of files from a working directory intended to be in the image in the end and available in the container when it's launched, you're copying everything. Think about what you're copying. You could be copying test code. You could be copying maybe even environmental configuration that shouldn't really be in a production image. You could be copying your .git directory. That's probably not the best thing. There's a lot of stuff that happens there. I noticed when I was going through this that my builds were taking forever, and it's because all of that material has to be passed to the Docker daemon in order to make it available during the build. And that process takes a long time. Lots of unnecessary activity there. And possible security issues if you're copying things you shouldn't be. Number 7, I see this a lot. I see it in a lot of examples online too of Docker files. I remember using this specifically because in our case we had to install some software that we had paid for, and this is how we did it. We grabbed the script from a link that they gave us, just curled it in, ran the script, and then our proprietary software was installed. The problem with this, now we were responsible enough to at least look at the script, but how many times do you think this happens when no one's even looking at the script? They just run it. You're just provided with a curl statement and you just run it. If you're doing that, probably not a good idea. Eventually what ended up happening with us, because we ignored this for a long time, is our build failed, and took a little research to figure out why our build was failing. Turns out this was no longer available. It was being pulled from some repository that the company we were using it from didn't use anymore. They chose to do something else with it, put it somewhere else. That happens all the time. So whenever you put your stuff that you need to build your project in the hands and responsibility of an external party, just be prepared to have things fail randomly. And the more you do that in the more different places, the more problems you're going to have. So at the very least, bring that script in-house, manage it yourself, update it on your schedule and not on someone else's schedule. I don't know if any of you get sick of having your computer keep popping up with, this thing is updating now and this thing is updating now, and I'm like, I'm up here giving a talk and I want this thing to be updating right now, right? I want to have control of that. So I know a lot of developers shut that down immediately. I feel the same way about stuff like this, stuff that I need to have reliability that is going to build on my schedule. All right, the last one, line 9, running as root. Obey that principle of least privilege and let that script only have the permission for what it actually needs. It's fairly easy to set up a user and group and make sure that you're doing that. Those are just a few problems that I've come across pretty frequently in Docker files. Definitely not an exhaustive list, but it's a pretty good place to start. So here's just to recap, since I care about containers and Docker images so much. Make sure you're using trusted or official base images. Don't use bulky parent images. Use multi-stage builds. That means making sure that you're not including build tools and stuff into your image. That's really not necessary. Specify all versions of all packages that you need to include in your images. Use that Docker ignore file. Get those external resources internal, manage them internally, and do not run processes as root. That last one, there was a report that Sysdig did, Cloud Native Security and Usage Report. It was out of 3 million containers that they were observing, and 76% of them were running processes as root. So I feel bad for harping on that one all the time, but clearly we're not taking that one seriously enough. Okay, so dealing with dependencies and artifacts that we have built, This is a slide that I see in our corporate deck quite often. I don't expect you to be able to see all the little things, but this is just basically the software development life cycle, all the way from the developer to deployment to production. What this doesn't include is like monitoring and everything that happens after you deploy to production. But look at all these places where we care about dependencies and artifacts. So this is step 2. This is a developer resolving dependencies. This is, getting these dependencies from remote repositories if necessary. Here's another one. This is our CI server, again, resolving dependencies, doing its build every time you check in. We've got one at the very end. When we're done with building, we now have this artifact we need to put somewhere. We've got to deploy it somewhere so that it's available for later use. And then that later use could be either, providing it for distribution elsewhere or actually deploying it to a production machine or service. So technically, everywhere you see one of those green connecting lines, that's an opportunity for disruption in your build and the delivery process. So we need to pay attention. We've got to talk about this more, dependencies and our artifacts and how they move through the system. There's efficiency issues as well as security issues that we need to pay attention to. This is a simplified version of that pipeline in the previous slide. So where we should be concerned, obviously in development, we just talked about how I'm in my local development environment and I'm pulling stuff directly from Maven Central and pulling stuff directly from NPM registry, all of that. Sometimes we need to be able to reproduce a build in order to fix a bug that we're looking at in production, so we care about where our dependencies and where our artifacts are coming from. This is what we do every day. We troubleshoot, we repeat, we build and design and do it all over again. Continuous integration, we talked about that. Some CI servers are misconfigured in that they continuously reach out to public repos when they really should be only doing that when it's not cached or when the artifact isn't already available in the system. And then ultimately we want to store our artifacts on a build success. We need to consider where we're putting them. By the time we get to testing, we need to move those artifacts around. They should not be rebuilt at this point. Once you've built it in continuous integration, that's it. You take that artifact and you promote that artifact through the rest of your pipeline until it either breaks, doesn't pass a test, or any of that, and then finally it can be promoted to production where everything has been checked off, everything's green. That is our release. When we actually, get a release put together, we want to make sure we're collecting the correct artifacts, that we're wrapping them with, a bundle that makes sense. And then ultimately, we want to be able to deploy these artifacts and not accidentally deploy something that maybe was inadvertently put in a repository with everything else, like that junk drawer in the kitchen. We want to make sure we're getting the right artifact. So yeah, everywhere you see this green connecting line can potentially be a problem. This is where specs like the Salsa, who has heard of Salsa? Worked with it at all? Okay. It just basically describes supply chain levels for software artifacts. It's basically best practices. How well do you handle all of these behaviors? And everywhere where you see this red triangle is potentially an issue. Now, as a developer, we're going to pay more attention to the stuff closest to us, which is all the dependencies that we resolved when we're actually doing our builds, and then our source code, and then our CI servers. We definitely are going to be paying attention to those. One of the most crucial areas to harden is your build process during continuous integration. Make sure that the dependencies you're pulling in are exactly what you expect them to be. They need to be the expected version. you need to verify they are a trusted dependency and not a malicious package that happens to have a similar name. So remember that SolarWinds hack we were just talking about. Apparently, their update server, they got hacked at the end when they're ready to provide their production asset to all of their customers. That step got interrupted, and their update server could be accessed publicly with the password SolarWinds123. If you're new to this landscape, you're going to make mistakes. I did some trial and error, like I showed with that Docker file earlier. The most important thing that you can do is make sure that you can respond to problems quickly. Just like as developers, we're taught that we're never going to be able to produce a 100% bug-free application. If you do, you aren't doing enough testing. It's just not possible. It's not feasible. It's all a balancing act. But when you do find vulnerabilities, when there are problems, and it will happen, make sure that your process is such that you can respond immediately, quickly, get your stuff updated. This is like maintaining a house. It's never done. There's always the yard to clean up. When I get home, I've got to clean up my yard for winter. Looking forward to that. There's a roof to repair if you have hailstorms like where I live. There's hot water heaters that blow up. These things do and will happen, same with software. So make sure you're spending the money to keep everything maintained, keep your versioning up, make sure that you dedicate time in your process to update all of your packages, just to make sure that you're keeping ahead of these problems. So quick review, how can a developer improve security? All these things, we can focus on writing safe code, make sure that you're taking advantage of the resources available to learn about your particular language that you work with, what are some of the patterns to be concerned about. Make sure that you're managing your dependencies appropriately, building your artifacts responsibly, like with the Docker file we just looked at, and then understanding, protecting, and maintaining your dev delivery pipeline. That means updating your stuff. Don't get complacent and think that if it's just not broken, I don't have anything to worry about. You may have some money to be paid out if you're thinking along those lines. Really quickly, some tools that a developer can use in real life. This is Frogbot. Very cute, very cool open source project. It uses JFrog X-ray for scanning for vulnerabilities. This is a way for you to manage vulnerabilities and detecting them at the point where you're committing into your source code. Another one, I use this one frequently whenever I'm utilizing a new Docker image or creating one or making modifications to a Docker file that I've been working with. I'll scan it locally using Docker Desktop. JFrog has a plugin there that can help you with that. There's lots of other scanners available. There's no excuse for us not to be doing this, paying attention to the changes that we're making locally in our environment before we even check in. This is another open source project that is dealing with supply chain security, and I'm wearing the Persia t-shirt today. We have some at our booth too. This is a project that is now incubating in the CD Foundation. How many of you have heard of the CD Foundation? How many of you have heard of the CNCF? Okay, so the CNCF is a Cloud Native Computing Foundation. Generally, people have heard of that one more. It's huge. It's behind KubeCon a lot. The CDF is Continuous Delivery Foundation, and it focuses mainly on the open source projects that are involved in continuous delivery. So a little smaller subset. These two organizations are sister organizations. They're underneath the Linux Foundation. There are a lot of opportunities to be involved in the projects that are coming out of here. Persia is one of them. Persia is an open source project that is creating basically a decentralized package network that has full provenance over all of the artifacts that you would depend on as a developer. It's starting with Docker containers, making sure that you can trust that you're getting a Docker container that is, or a Docker image that is what you expect it to be. And it basically it works on this decentralized idea so that there are multiple trusted nodes that have to agree that this particular artifact is what it says it is in order to prevent, any nonsense with someone trying to insert a package that is not legitimate. This is also meant to work for languages like Go that actually are built directly from source. So one idea is that this decentralized registry would take that source. Several trusted nodes will build that source and make sure that the hash is the same. If it is, it gets marked as okay, and future use of that artifact is considered safe. Interesting, just trivia on the Greek origin of Persia. It had to do with, lighting messages, multiple messages between multiple mountains, making sure that everyone was in agreement that things are happening the way they should. We talked about the security model already a little bit. There's more information about Persia at the booth. This is something that I'll be talking about more and more as we get more and more developed with this project. We are looking for contributors. Oh, one more thing I wanted to share. This is really cool. And then I'll open for questions. This is my IDE. I use IntelliJ. It's my favorite. And what we're looking at here is just a POM file of a project that I pulled down. It's a Spring Boot project that I've been playing with, toying with, trying to make it better. And one of the things that I've hooked up here is a plugin. It's a security vulnerability plugin that tells me if there are any problems with the packages and libraries that I'm bringing in to this POM file. What's really cool about this is before I even make any changes or check any of this code in, I know for a fact there's a better version of Spring Boot Starter Parent. I'll just put 2.7.4. I'll update it and I'll take a look at it, and I can tell live that there's definitely improvements. Not perfect, but it's improved. This is something a developer can do right in their development environment before they even check their code in. It helps. It helps the whole process so that this doesn't get flagged immediately all the way at the end in production. So just an example of what can be done. This is the Jfrog plugin, Jfrog IDE plugin, and it supports multiple IDEs, not just IntelliJ. It's just my choice for today. Yes. Yep. Publicly available. It does operate on X-Ray, which is a product of JFrog, but it is there is a free usable version of that, which is nice. If you're gonna, just as a developer, you can set up your own instance and be able to use that to get a majority of your problems covered. It's interesting to analyze too. If you have a full-on security team, it's nice if they have policies set up so that some of this stuff gets filtered for you before you even see it, because really, as a developer, seeing all this red can be a little overwhelming, and some of it isn't applicable to what you want to do. So making sure that you're paying attention to the analysis, which that's also provided as part of the explanation in the plugin. You'll be able to tell if, through context, if this is something that you should really be concerned about or not. All right, that is it. That's all I have for you today. If you'd like to contact me, I am at Melissa J. McKay on Twitter. I am in the process of getting another social media account. I bet a lot of you are as well. So I'll start putting that in my slides in the future, but for now, this is where you can find me. Don't forget stickers. Cool JFrog stickers.